In this example, we're going to practice powers of exponents, and we're going to simplify the following bases and powers. So in part A, negative 2 to the fifth power. And notice that the negative is inside the parentheses. That can make a difference in some problems. In this one, it won't really matter, but it could. So let me just start by saying that you could just take 5 copies of negative 2 times itself, and that is sort of the definition of what that power means. So negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And, you could just multiply it out with your calculator, or you can kind of even count on your fingers in a way I'll describe in a second. But I'm going to help you understand it so that you don't only have to plug it into the calculator. So, first of all, ask yourself what happens when you multiply two negative numbers together. And I hope you remember that they cancel. The negatives cancel and it's positive. And then ask, well, what happens if you multiply 3 negative numbers together? And if 2 of them makes it positive, then 3 should make it negative. And then similarly, in fact, 4 negative numbers would be positive, and 5 negative numbers together would be negative again. So this is going to be a negative number. And then we've kind of taken care of all the negatives. You can just ask yourself, what is 2 to the fifth? So let me put parentheses here so that reminds you that it's negative, and then whatever the result of 2 to the fifth is. And here's where you can count with your fingers. You can just use a finger for each 2. So you hold up one finger and as I have 2. And then hold up 2 fingers, I've got 2 times 2, that's 4. Hold up 3 fingers, I've got 2 times 2 times 2, that's 4 times another 2, that's 8. And then times another 2 is 16. And then times another 2 is 32. And that's where I stop because I'm now holding up all 5 fingers. And so this is negative 32. Okay, part B. Let me start by rewriting it. So x to the 17th over x to the 22. So the rule for when you have powers and exponents on top and bottom of fractions is that you subtract the power that's on the bottom, or if that's the only place it is, then it's a negative power. So here, this would be x to the 17 minus 22, and so that's x to the negative 5. And you can leave it that way. There are no directions that said otherwise, but sometimes people would like to rewrite it as well as 1 over x to the fifth. And again, the definition of that negative power on top, the negative there, 5, the definition of that is that it should be 1 over that base and power on the bottom. Okay, let's look at part C. So there's 2 different things going on in part C, 4 to the negative 3 halves, and one of those things is the negative power and the other is the fractional power. But we've already talked about the negative power in the previous part, so let's do that first. What that means is that we should have something 1 over 4 to the 3 halves. That's just like in the previous part, where the negative on top means we should have 1 over that stuff on the bottom. Okay, well now we have to figure out what to do with that fractional power. And I'll just go ahead and say it, or remind you, that fraction, the half part there, that means that you're taking a square root. And so this is 1 over the square root of 4 cubed. Or if you can also do it another way, it doesn't matter. You can say this is 1 over the square root of 4, and then have the cube on the outside. Whichever way you like, they are equal. So I guess the second way to write it's a little better for us to simplify, because the second way is something I can take the square root of. So this is 1 over, and instead of the square root of 4, I'll simply write 2. And then it's 2 cubed. And so finally, that's 1 over 8. Okay. So there's parts A, B, and C. Let's take a look at part D. So the square root of 36, x to the 4th. This one we don't particularly need to talk about powers and properties that they have, but we just need to, well, I guess maybe one of the properties that they have is that you can apply them to different parts of a product. The square root is a power, and this is a product. Anyway, the long story short is I can take the square root of 36 and multiply it by the square root of x to the 4th. Okay, so hopefully the square root of 36 is pretty easy to figure out. That's just 6. And then the square root of x to the 4th is x squared. Now, I'm not sure if I thought of the best example here, because there might be two different ways you might be guessing or thinking about what happens with x to the 4th to turn it into x squared. You might think, well, I subtracted 2 from 4 to make 2, or I divided by 2, or you might think I took the square root, and they all kind of come out the same way. So let me make it really clear. The reason this worked, the 4 on top turning into the 2, is this is actually, from here to here, this is going to be 4 times 1/2. And the 4 is what we were given, and the 1/2 was because of the square root. So the square root is what gave us a multiplying by 1/2 power on top. So your answer, if it had been x to the 6th, would have been the square root would have been x cubed, because you would multiply the 6 by 1/2. So anyway, the final answer here is just 6x squared. I just wanted to explain that.